Video, we're going to learn about different types of variables. We have an idea of what a variable is. It's just that quantity or quality that we measure. And we're going to talk about what we can talk about with those variables and what we call them. The reason we do this is it's helpful to know what kind of variables you have so that you know how to actually summarize them and do what we call exploratory data analysis on them. And that depends on the type of variable. So the first type of variable we're going to have that we're going to look at are what we call qualitative or categorical. So qualitative is just a quality we're measuring. So this is just some kind of quality that is measured from a unit of observation. So example, and these sometimes are called categorical. I prefer actually categorical over qualitative because the other one's called quantitative and I get them messed up. So categorical is another way to think of it. It's just a category. You're just putting them into some kind of category. Some examples of these would be things like hair color, um, race, ethnicity, um, I can't spell ethnicity. Ethnicity. There we go. Um, and then things like religion, things like gender, grades. And when I mean grades, I mean like letter grades. So maybe I better say letter grades. Things like place value, like where you are running a race. So place in a race or ranking. Some other things are that you could measure for qualities is opinions. You could also measure the size of something in terms of small, medium, large. There are lots of other things we could do for these qualities that we could have, but the main thing is that these are words. I do want to be careful. More in the past, not so much now, but even now we still do this where you might put things on a scale. You might say from 1 to 5, what do you think of this? Especially like if you do rankings, when you're going to go to a hotel or a restaurant, you would say give it a scale of 1 to 5, 5 being really good. That 5 really doesn't mean anything. So don't think of these as being these numbers are inherent. That 5 is not an inherent number. That 5 is not the same to you as it is to me. So be careful with when you see numbers, make sure those numbers are real numbers. If they're not inherent numbers, then they're still a quality. When we put things on those scales, it still is that. When you do pain levels of saying you're pain from 1 to 10, that still is just a quality. It's just that we gave a number to it because people seem to like numbers. So those are our qualitative or categorical variables. The other ones are quantitative, and quantitative is where we have numbers that represent some value or quantity if you want. Some examples of these we would have would be the height of somebody, the weight of somebody. Another example might be the distance, the time to do something, the number of cats a person has, the number of tattoos a person has. You might be doing some kind of quantitative where you're looking at the price of something, or you might look at the salary. So these are all examples, and there's certainly way more. It depends on the question you're asking. With quantitative variables, these are all numbers that are inherent. These numbers mean something, they have a purpose behind them. Because of that, we can also talk about these numbers as being these kind of variables being kind of certain kinds of things. Discrete means they can only take on specific values. So, as an example, if I'm counting something, I can't count half of a cat. I can't count half of a tattoo. I can't count half of a um an ice cream scoop. So these would be examples of things that I'm counting. They don't only be very specific values. Another example is actually shoe size. I can't buy a 10 and 3/4. I can buy a 10, a 10 and a half, a 9 and 8, those things. So they can only take on very specific values. Continuous are variables that you can be any value in a range. So examples of these would be your height. Granted, we say we're 5'6", but really we're not. We're 5'5.3" or something like that. Your weight, you could also depends on your measuring device of how accurate you give, but you can still be any value in that. Distance, time, it all depends on what we're actually measuring. So those would be what we call continuous variables. One thing about these variables is the measurement levels are important because it tells us kind of how we actually can analyze these. So nominal variables are variables that can only have, there's no order to them, no value, no numeric values. Mostly is that there's no order, which means you can't do anything with them. You can't add them, you can't subtract them, you can't do anything with them, you can't even put them in order. And so nominal things are like hair color, race, ethnicity. Um, these are all things that we can collect off somebody, but we can't put them in any order. There's no order to any of these numbers, these things, these variables. Ordinal are basically nominal variables, but we can now put an order to them. So we can now put them in order. So these are things like rankings. If you say I'm going to put something in order from 1 to 5, 5 being the highest, that's a ranking. I can actually put them in order. Some other examples are grades. You can put them in order from A, B, C, D, and F. Um, if you were to do age groupings, like you were going to say adolescent or infant, adolescent, teenager, 20-year-old, 30-year-old, elderly, whatever, middle age, wherever we want to go with it, that would be an example. You're not using the numbers, you're just saying where that person belongs, where that number belongs, or that value belongs. Um, Interval variables are also ordinal variables. So notice they're all kind of building on each other. So ordinal variables where the difference between values makes sense. So as an example of this, and there's not a whole lot of these, but an example of this is temperature. On the Fahrenheit or Celsius scale. Um, and what I mean by this is I can say that something is warmer. It's going to be 20 degrees warmer today than it was this morning. It's going to be 50 degrees today, more today than it was in the wintertime. I can talk about that difference. What I can't do is say it's gonna be twice as warm. That doesn't make any sense to say it's twice as warm. All I can say is how different they are. Another example, this is time on a clock. I can say that it's 8 o'clock in the morning and then something is at 5 o'clock in the afternoon. I can talk about what that difference is between those times. I can't say that it's twice as long or twice as far. I'm twice as time. That doesn't make any sense. See, I can't even say it because it doesn't make any sense to talk about it. So length of time is more than or interval because I can talk about something taking twice as long, but time or clock doesn't make any sense. The next one, the last one is what we call ratio, and this is where basically they're interval values. So we can talk about the difference between them, but it's also where the the ratio of values between values makes sense. So as an example for this is like weight. I can talk about something being twice as heavy as something else, and that makes sense to me. I understand what that means. I can say that something takes twice as far, so distance can be talked about that way. And there's other examples of this. Even length of time can be also thought this way. So these are all examples of ratio. The main thing about ratio is it has what we call an absolute zero. And what that zero means is the zero means absent of the object. There's nothing there. So an absolute zero means there is no value there. So that's what an absolute zero means. And ratio values have an absolute zero. If something has a zero length, it means it doesn't have any length. If something has a zero time to do something, it means it doesn't take any time. Interval, zero on a clock, just means it's midnight. Zero temperature in Celsius means water froze. Zero temperature in Fahrenheit just means it's really, really cold. So that's kind of what that absolute means. And those are kind of some ideas. And the reason we deal with these is that it gives me an idea of how to now analyze the data later.